Once we know how much R or S isomer are there in the solution, the next step is we have to separate them. Okay, but a little bit problem with the separation of a pair of enantiomers because they have the same property, right? The only difference is just optical activity, but the rest of the property are exactly the same. So it's kind of very difficult to separate them. You can't use just regular column chromatography. You can't use distillation. They have the same boiling point if they were liquid. You can not use, if some of them are solid, you can't filter it. I mean, it's just a problem. But we have one technique called chiral column. Okay, what is chiral column? So this column will be loaded with an absorbent, right? Absorbents that can interact with one isomer than the other. Okay, so let's say if this absorbent can interact with the R isomer, you know what absorbent is? Interact with something and it's stuck it in, right? So when you load R and S mixture into this chiral column, the absorbent will interact with R, slow down the R isomer for traveling. S isomer gonna be just go through it right away because it has no interaction with the absorbents. These absorbents can interact only with an R isomer. By the way, the absorbent usually a chiral compound that can interact with just an R isomers. Okay, so S isomer gonna come first, travel real quick, come out first, that, and R isomer gonna be slower, stay in the column longer. That's how we separate them. All right, let's talk about the application of stereochemistry. We're almost done here.